The cross product of two vectors is a vector product that takes into consideration how perpendicular the vectors are. The more perpendicular the vectors are, the larger the cross product. But parallel vectors would have a cross product of 0. For each pair of vectors below, say whether the magnitude of the cross product will be 0, or a maximum, which is A times B, or will it be something in between 0 and the maximum? For number 1, because the vectors are completely parallel with each other, there's a 0-degree difference between them. The magnitude of the cross product is going to be 0. Parallel vectors always have a 0 cross product. But here, where A and B have 90 degrees between them, that's the opposite. The cross product magnitude will be the maximum that it can possibly be. And that is simply the product of the length of A times the length of B. When the angle between vectors A and B is between 0 and 90, then we'll have something in between. The formula which will give us the magnitude of the cross product will be similar to the formula for dot product, but instead of AB cosine theta, we're now going to use AB sine theta, where the theta is the angle between the vectors. Here, A and B are completely perpendicular, so we'll have the maximum cross product, which is A times B. One way to think of it is it makes a rectangle, and the cross product is the area of the rectangle, A times B. Here, however, our A and B are not at 90 degrees with each other. What we'll do in that case is create a parallelogram. And the area of the parallelogram is going to be the magnitude of the cross product. So it's going to be between 0 and A times B. It will be AB sine theta. That'll be the area of that parallelogram. Here, A and B are in the same direction, so our cross product will be 0. This time we have an obtuse angle, and so when we create our parallelogram, we're actually still going to use the same formula of AB sine theta. So it will be between 0 and AB. These vectors are anti-parallel, going in opposite directions with 180 degrees between them. So the cross product here will be 0. Here our vectors are at 90 degrees with each other, so we'll have the maximum cross product, A times B. Note that the angle that any one of the vectors is pointing doesn't really matter. What matters is the angle between those vectors.